RAG failures are not always missing context. Sometimes the retrieved sources disagree, and the model averages them into a confident, wrong answer. This is the pattern you'll be able to implement by the end, which flags conflicting evidence and reroutes the answer plan. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. When you use retrieval augmented generation, the system fetches documents and then writes an answer from them. The common failure mode is disagreement between sources. Models often treat that as noise and blend a plausible but wrong response. You see this in product reports, knowledge bases, and finance notes. Any place where numbers or trend directions conflict. A practical system should catch those conflicts before generation and either ask for clarification or exclude the risky evidence. What we want is a lightweight gate. Turn retrieved text into discrete claims. Normalize those claims into comparable facts. Measure disagreement across them. Then decide, generate or pause and clarify. This pipeline works well for small to medium corpora and keeps latency low because most of the work is simple text processing plus a few pairwise comparisons. The idea is straightforward. If two documents say opposite things about the same subject, flag it. For numeric claims, we parse a value and a verb, like grew or fell, so we can judge both magnitude and direction. For topical disagreement, we group claims by subject headings and look for mixed directions or wide numeric spans. That gives you both scalar signals and topic-level warnings. We will build a teaching pipeline that normalizes retrieval into facts, extracts numeric claims, scores pairwise conflicts, groups by topic, and then gates generation when disagreement is severe. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. First, we clean and split the raw retrieval output into atomic statements so comparisons are consistent. This snippet turns retrieved chunks into a clean list of facts, so later conflict checks are reliable. The docs list stands in for your retrieval output, with each entry keeping a chunk ID and its text, so you can always trace a claim back to its source. The comprehension splits chunk prose into sentence-level facts and trims stray punctuation, which keeps downstream comparisons focused on atomic statements instead of noisy formatting. Fact total sums how many facts we produced, so the printed total confirms the normalization preserved the evidence you expect. After this step, you'll have a mapping from chunk ID to source text, plus a short list of sentence facts ready for parsing. Now, we need to turn those sentence facts into things a machine can compare numerically and directionally. This example pulls numeric claims and trends out of each fact, so quantitative disputes become machine-readable. The compiled regex captures verbs like grew or fell along with the first number in the sentence, giving us structured access to the stated magnitude. The comprehension building quant claims stores the chunk ID, the parsed float, and a trend label inferred from the matched verb, so later stages can reason about both direction and scale. The spread window print reports the numeric span across extracted values, which already tells you how far apart the evidence sits before any semantic checking. Parsing like this separates magnitude mismatches from outright directional contradictions. Simple extraction isn't enough. We must rank which disagreements matter most, so a human or a clarification agent knows where to focus. This snippet scores evidence pairs by how strongly they disagree, combining value gaps and opposing trends into one severity metric. The combinations iterator walks every unique pair of quant claims, so each document pair is evaluated once without double counting. Direction mismatch. boosts severity whenever one claim signals growth and the other signals decline, while the absolute difference captures how far their reported magnitudes diverge. Sorting conflict pairs and inspecting top conflict yields the most problematic pair. So the printed tuple and score point you to where arbitration should start. The severity formula is adjustable. Raise the direction boost if you want opposite trends to dominate the score. Finding bad pairs is useful, but we also need to know whether an entire topic is unstable across many documents. This snippet groups claims by simple subject headings so you can flag multi-document disagreement zones. The topics dictionary aggregates claim IDs using the capitalized heads from each fact, giving you lightweight topic buckets with no extra metadata. For each bucket, we gather the matching quant claims, measure the numeric span, and check whether multiple trend labels appear. Either condition signals unresolved tension inside the topic. Needs review collects the topic keys that triggered a warning, so the printed list shows which evidence clusters require intervention before generating an answer. Topic grouping is intentionally forgiving and helps avoid overreacting to single outliers. Finally, we pick which statements are safe to keep and which require human or system clarification before generating an answer. This code runs the decision gate that either forwards safe context to the generator or pauses for clarification. Conflicted IDs expands the needs review topics back into concrete chunk identifiers so you can surgically remove risky evidence instead of discarding the whole retrieval batch. Safe context keeps only claims outside those hotspots. And severity block compares the top conflict score against a high-risk threshold to make the gating condition explicit. The final response plan print confirms whether the pipeline will generate or request clarification and shows how many vetted statements remain to ground the next step. This gating approach preserves useful evidence while reducing the chance the generator uses contradictory inputs. In a real project, you'd wire safe context into your prompt builder and log conflict signals for tuning. That gives you metrics on how often the gate fires, which topics trigger most, and whether clarification requests actually improve final answer accuracy. Recap: we built a compact pipeline that normalizes retrieval, pulls out numeric claims, scores pairwise and topic-level conflicts, and gates generation when disagreement looks risky. Use this whenever your RAG system handles factual or numeric claims that need trust reports, documentation, finance notes. One caveat: heuristics can miss nuanced language, so expect imperfect recall and plan to tune the parser for your corpus. Next step: tune the high-risk threshold and the numeric spread window to trade off safety and coverage for your corpus. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.